Welcome back to Uncle Fish. Today we are going to talk about arrays. And I'm not talking about what you've been likely begging for at work that you're not getting, but a different kind of arrays. Arrays in the context of C++ are data structures. There's lots of different kinds of data structures. We'll talk about those in subsequent videos, but today we're going to focus on one of my favorites, which is arrays. So if you've been following along and learning with us, we've gone over types before, right? We've gone over int and chars and floats and doubles and all of those types of things. But we have always talked about them kind of in a singular fashion, meaning int a equals 6, right? And then we go use a subsequently in our program. And if you remember, what this really was translating to from a system perspective was in an area of memory, right? We had this block where we were storing 6 in, and this was referenced by some address, some kind of cryptic address, but we didn't want to know the cryptic address. We wanted to call it A, so that way it would be easy for us to learn. And A would point to that address, and that address would then point to this bucket in memory, and that would tell us where the value of 6 is, okay? And then we can go update that value and do lots of changes, hence the name variable. But again, this is really singular, right? It's one number, one location in memory. What if you have to store like 100 of these or 1,000 of these? How do we do that? Like, we don't want to say int b equals this and int c equals this and so on. So this is where these data structures come in to help us. So an array basically is, think of it like as a collection of the same type, right? So let's say int, like in this case int. So it's a collection of some type, but it's the same type, right? In memory. So that we can go off and access it and use it and do lots of things with it. So a simple example of this would be, let's initialize, for example, an array or declare an array for int. Let's say we're going to store like 10 of these. So how would we do that, right? So we would say int, meaning this is our type, right? Our data type. And we would say numbers. This is just a name I'm giving it. And then we would do the square bracket and put in something in here. So we said we wanted 10 elements, right? So 10 is what I'll put in here, but basically what this is the size of the array. Okay? And there's something special about arrays that we'll talk a little bit about later, but these are, the default ones are called fixed size. And there's a reason for that, okay? But the fixed size arrays is basically that we have to tell it at compile time that we want to have this many, right, of these types of ints. So, and there's a reason for that. So let's go talk about that here for a second. So first, let's visualize this in memory. How does it look in memory? So I'm going to erase my simpler example here, and let's go draw a little bit more complicated one now, right? So in here, let's say again, we have our memory. Try to draw a bigger rectangle here. I gotta really work on rectangles. Like, this is so ugly. So, all right. So we said we wanted 10 of these elements. Now, int has a type, and there are a known size of different kinds of ints. So, for example, in the basic int, let's say that that's 16 bits, right? That's associated with this particular type. Okay, great. So what we will do then is we will say we want 10 of these, right? 10 of these buckets. So there's, should have picked a smaller number. Right? What is that, like 4, 8? We'll do the other 2 over here. All right, so there's 10 of these buckets. And again, really important to think of this as contiguous in memory. So side by side by side by side by side, right? So we are telling the system, hey, I want you to kind of reserve this amount of space for me in memory, side by side by side, 10 of them of this size. And then I'm going to store 10 values in there of this type int. Okay? So this is essentially what we're doing in memory. And what is numbers going to translate to, if you recall from the last one? So numbers really is this spot right here. So there's an address at the very beginning of this contiguous block. And that address is what we're going to call numbers, so that we can go in and reference it. Okay? So anytime that we say numbers in our program, we're actually coming to this spot in memory in the pointer, basically. And from here, we're going to work our way over to the right. So I'm just making this up. Let's assume we put, 1 in here, or we put 3 into the first one. First of all, let's talk about how do we do that? How do we actually add a number into that spot, right? So in order to reference the position of any of these buckets, they are often referred to as indices or index, okay? And these indices, they start at 0. This is always very confusing to students. They start at 0. So if you want to reference this guy, this bucket, you would say numbers, open bracket, 0. That's this one, okay? If you want to reference the second bucket, it would be numbers and 1, and that's this bucket. And so on and so forth, okay? So numbers 9 would then be this guy, okay? Numbers 10 is a problem. There is no numbers 10 because we declare this as a fixed size array, and you would be out here basically and get some kind of an exception in most languages, like an index out of bounds exception or something like that, okay? All right, so you know now that we've allocated something, you know that we can kind of move along here and do some assignments into these areas or buckets, okay? Let's talk a little bit about how this actually works under the covers. Like, how does it know to move from here to here to here to here? Because remember, again, every time you give numbers, you're actually starting with this address, like right here, the first one. So there's some what's called pointer arithmetic that's happening here. And pointers, we will talk about in subsequent videos. So for now, just kind of bear with me. But imagine that what we're saying when I say numbers and I want this, fourth spot, really what I'm telling the system is go over to this pointer, right? That this starting address. This is of a type n, so it's 16 bits, let's say. So I want to move the pointer 16 bits, and I want the fourth element. So I'm going to do it 4 times, basically, okay? So that means like you start here, move it 16 bits, now you're here, move it 16 bits, now you're at this guy, move it 16 bits, and you're at the beginning, of this guy, and that's the one that we want. That's the 4th move, and then whatever element is in here, you can set it or retrieve it. All right, I hope that makes sense as to how these things work. You can also take this construct now and do lots of cool things with arrays. You can go off and you can do multi-dimensional arrays, for example. I'm going to erase this again. Always find this part really therapeutic. All right, so you can do multi-dimensional arrays. You can say I want int, sorry, let's scratch that. I'm going to say int matrix, for example. And I'm going to do 2 brackets, right? And I can give different sizes. I can say I want 2 and then let's say 4, right? And so now what you're going to get is a matrix basically of one array that's going, this way, and then another array that's basically going down. So you're getting a matrix, okay? So 2 is for the rows, and 4 is for the columns, right? And so what that means is that I shouldn't have drawn this here, right? But basically I want it to look like this. So I want 1 spot, 2 spot, 3 spots, 4 spots, 1 spot, 2 spot, 3 spot, 4 spot, right? And so you can build matrices now with this and have, a wide variety of different data storage capabilities. And it becomes, again, really powerful. And referencing this is, again, going to be the same way. So you can say, if you wanted to reference this spot, right? Well, this is the 0 element of the first, right? So it's this row, right? And it's this column. So 0, 0. 0, 0 would point you to this one. As you want to move to the right of that first array, you would say matrix. Again, I'm on the first row, second column, and that would take you to here, and then so on and so on. And it would take you from here to here. And it's the same basic pointer arithmetic that we just talked about, okay? And the same goes now if you want to go down one. You can say, well, now I want to be on this array, matrix 1, so now you're over here. Okay, on this point, I should say, you're here, and I want the first element of this second. Okay, please disregard that little negative, that was an accident. that make sense? Right? All right. I don't know why I asked you if it made sense, as if you can talk back to me, but whatever. All right. So one of the things that we also want to describe here when we're talking about arrays is how and why and when you might want to use them, right? So we talked again about like this fixed size element, right? So there's a reason why it is a fixed size. Again, we need to tell the system that we want X amount of memory that is contiguous, and there's a reason, because the memory that this array typically gets stored in is called the stack, and that memory is precious. There's not that much space to it. We'll talk later about like what the stack is and what the heap is and how your program kind of executes. I think I'll do that in the foundations playlist instead of here. But the idea here is that this contiguous spot of memory is put into the stack, and you get some benefits when you do things on the stack. Stack is also where you have like variables and other things in your program. But the stack is faster. It's still in memory, but it's faster access, and it's automatic deallocation. So you kind of don't have to worry about cleanup. So as you move along, and you dereference a particular array inside the stack, it'll get cleaned up for you automatically. All right, and this is in contrast to vectors, which we'll learn later. But there's a reason as to why we have to tell it, this amount of memory is being reserved for us. All right, so now what we'll do is shift gears as usual. Hopefully this stuff is making sense. And we will go to the programming aspect of things now. So I'll switch screens as we do normally. And what we'll do in this particular case is we will walk through some code and see how these things work in practice. Okay? So in typical fashion here, right, what we're going to do is walk through here. I always ask the students to like pause the video here, look at this code, try to understand what's going on here, and imagine or predict what you think is going to get output on the side, right? So we're going to assume you finished the pause and now you're back, and we're going to go run this code, and then we'll walk through what it's doing. All right, so the first part here is pretty straightforward, right? We're just declaring and initializing the arrays, okay? So you can do this in one step. You can say, int numbers 5. So again, type is int. The name I'm giving it is numbers. I want 5 spaces reserved for me in memory. And in this example, I'm actually setting the values straight away. So this is called initialization of the array in the declaration statement. You can also do this separately and say int 0, numbers 0 equals 1, numbers 1 equals 2, right? Like what we talked about. Here we're declaring a type of char, single char. Of greeting array, and we're going to put hello world into that array. And this is just a variable size array of 8. We'll show you what that is later on. All right, so let's access the elements here. So the first element of the numbers array is 0. I'm sorry, it's 1, right? So I tricked myself here, right? So numbers having that index, so remember the index here is 0, that is pointing to 1. If I make this 1, that's pointing to 2. If I make this 2, it's pointing to 3, right? So remember, we're kind of moving along, and the beginning is always 0. All right? The greeting message. So the greeting message is we're basically taking this greeting array, and you notice that it's able to print it straight out. And so you see it's hello world, right? Right here. And now we're going to go in and see how we can modify an element. So we take numbers here, and we're saying the second index of numbers is going to be set to 10. So what is the second index? Remember, this is the 0th index. This is the first index. This is the second index. Okay? So this number 3 should now be 10, right? So we're going to go in and say, hey, the modified third element for the numbers array, again, numbers at this index, 2, is in fact 10 over here. All right? What we're going to do in the next one here is here, we're looking at this concept, and this is a little tricky, right? So this is why it's in here. So I'm saying I want a type int, the name is going to be array, and then I'm actually going to pass it a variable. So think about that for a second, right? We said that these are supposed to be fixed size things. So fixed size by nature is not a variable, it's a fixed size. So I am adding this and saying it's int size of array 8. So it's able to read this from memory, and now I'm going to declare an array of size 8, okay? But look what I'm going to do after this. So I'm going to go in and now set that variable. size array, and I'm going to multiply that, this is the star equals, right, times 2. So now the size of the array, or this value here, has become 16. But what does that do to my array? My array was supposed to be fixed size, right? And so I'm going to access that here. So what do you expect to happen? Array 15th element, which is the second to the last one here, right? I'm setting this to 999. So what do you think is going to happen here? Should there be a 16th element here? So if I go off and get this, you'll see that there is in fact a 16th element, right? So it says, should there be a 16th element, and it is, and it's set it to 999. So how is that possible, right? We should have gotten some kind of compilation error. We just talked about this being a fixed size. Well, so C++, as it's kind of gone through the different versions, they've put some safeties and some other things in there that allow for you to get beyond this with some variable size arrays under the covers, right? And they're not throwing compilation errors, okay? Now, similarly, if you look here, you see numbers 446, right? So I want the 446th element of the numbers array. Well, I mean, there's no way I set that, right? This should absolutely error out and give us something. So what does that number look like for the 446? We see that it is in fact correct. It's setting it to 100. Again, like, how is this doing that? So there are things that are happening in the newer versions of C++ that we take for granted, and that is allowing for this kind of stuff to happen. Don't take that for granted in other languages, right? There's other things where you're not going to get that benefit. If you start to allocate things to fixed size arrays, you'll get index out of bounds exceptions and other odd behavior, okay? All right, so we've talked here so far about your basic arrays, your fixed size arrays, and I think there's a term for it, it's like variable val arrays is the one we just talked about here. But there's another standard array here that's in the standard library called array, and it's a little bit different than your default fixed arrays that we've been talking about. So this now is, again, it's to help programmers so that you don't have to go off and do this on your own every time. We've come along and now given an object called array and added a whole bunch of features to that thing, right? And so that's what this is. So here I'm declaring an array of type int, and I want it of size 5. Notice that it's different than the way that it was before. And I'm going to call it a fixed array, and I'm initializing it to these different values. And then here I'm going to do my array, same thing, just call it a different name with these same values. But notice that here, if I'm accessing the elements, it's very similar to before, right? You say my array, what's the 0th element? You should expect to see 10, okay? But we get these cool features that we're going to show here, right? So for example, you can get features like size. So we can go in and ask basically, hey, count the number of elements that I have in this particular array. I can go check if that array is empty. I can, under the covers, it'll go to each element and each spot in memory and tell me if it's an empty or not. Okay? You can do things like fill. You can say, hey, I want to take my array and I'm going to put every single value set to 100. You can't do these kinds of things like with your standard arrays. So you see here, like we're printing that out after filling and everything became 100 with just one line of code, right? You can also go in and, for example, swap one array with another array. You can say the other array was 200, 300, 400, 500, 600, right? They're still of type int. And then my array, I'm going to swap it with the other array. So what do we expect is going to be now in my array? Notice, right? So my array here was 100, 100, 100. And after swapping it, my array now magically has the same values as the other array. Okay? So lots of really cool things that you can do, powerful things that you can do with this version of the array. So again, most students are going to gravitate towards that because there's lots of features and ease. But it's really important to understand those other things. It's really important to understand how some of this stuff works under the covers in memory so that you can see, why you're using something and when to use it. All right? These down below really was just to show, hey, you can do multi-dimensional. And again, the first one was the number of rows. Second one was the columns. We're making a matrix here of characters. And basically this is just a few for loops that are going to go out and basically put a star here. So I'm printing, a a rectangle here, and that's all this is doing, but not a practical purpose to draw something, right? But just to, again, illustrate the point that you can do lots of things. So imagine like a Sudoku puzzle or other types of stuff, right? That you want to store kind of in a table or matrix type format. You can do that here with multi-dimensional arrays. All right. So lastly, we put this in here. I didn't run it; it's commented out. But what do you think should happen here? So we're using the out. We're saying size of numbers. So numbers was our fixed array size here, right? That we set to 5. Then we grew over time here. But what do you expect to happen here if I say numbers.size, right? So if you execute this again, pause, go try it on your own. But the answer is you should get an error. You should get a compilation error because numbers.size, and we'll try it here real quick. But numbers.size, there is no such thing as that because this is not a standard array object that we're using. We're using the regular fixed size array, and there's no such thing as size in those things for that. So let's try it out here. So see, we're trying to compile it, and it tells you, hey, the request member of size in numbers, there's no such thing for this because this is your fixed size array. All right, hope that's helpful and it all makes sense. And stay tuned, we're going to do the next level of a data structure, which is called vectors. And vectors, again, are very similar to arrays, but very different from arrays at the same time. Thanks again.